I would like to acknowledge the unceded land on which Beyond Benign operates. We are located in the state of Massachusetts, which has been the traditional land of the Pawtucket and Massachusetts Nation. We acknowledge the history of this land and encourage others to acknowledge the unceded lands and territories belonging to the indigenous nations across the world and wherever that you are tuning in from. We would like to also pause just a moment to give thanks to our sponsors who are making this series possible. Beyond Benign is an organization working to foster a green chemistry community that empowers educators to transform chemistry education for a sustainable future. It's our vision to ensure the chemical building blocks of products used every day are healthy and safe for humans as well as the environment. And we believe that education is the most powerful and critical component to achieving this. Beyond Benign works across the educational curriculum by investing in educators, fostering peer support networks, and developing tools and resources from K-12 all the way through industry. The reality is that there is a demand for green chemistry skills, and we don't currently have the workforce equipped to solve sustainability problems using chemistry. So we are excited to feature presenters here monthly who are working to change this at the K-12 level. As a thank you for being a part of our green chemistry community, we are giving away 5 copies of the book, Green Chemistry, Theory and Practice, signed by Dr. John Warner, written by John and Paul Anastas, co-founders of the field of green chemistry. This book introduces the design, development, and evaluation process of new green chemistry methodologies. So enter by Earth Day this year, which is April 22nd, for a chance to win. Our goal tonight is to have an interactive session to share with you a middle school curriculum for sustainable invention using the core ideas of green chemistry. If you have questions during the presentation portion, please just type those in the chat, and we will have time to have breakout sessions into smaller groups for discussions as well later. So please let me now to introduce our guest presenter. Erin Mayer has the amazing privilege of facilitating the learning of scientist explorers at Casey Middle School in Boulder, Colorado. She has been working alongside young learners for over 20 years to create safe and open learning environments filled with opportunities for learners to lead their own learning as they connect with and develop deep and enduring understandings of the natural world. She challenges her student learners to be inspired learners who think critically, ask questions, and design solutions. She encourages learners to think big and broadly, discovering and cultivating their strengths, talents, curiosities, and ideas as they address local, national, and global issues, ultimately empowering them to take action and make our world a better place. Now, this is where it gets weird because I have to do my own bio introduction, so I got to switch into third person here. I'll just do it in first. I was born and raised in a very small town. Again, my name is Greg Sloan, in southeastern Indiana along the scenic Ohio River in the tri-state region of Indiana, Ohio, and Kentucky. Being a first-generation college student, I began my undergraduate program actually as a music education major at Indiana University. It was my interest at that time in biology that lured me into switching my field of study to science education. I began teaching science in Terre Haute, Indiana in the fall of 1992, and I continue to this day teaching middle school science. I received my master's degree in administration and supervision in 1999 from Indiana State University. Over the years, I have worked on curriculum development projects and teacher training programs for Pfizer, the Keystone Center, as well as Beyond Benign. I currently, obviously, host the Observe, Wonder, Think monthly green chemistry education webinar. This curriculum work has allowed me to facilitate discussions across the US, as well as Toronto and Sydney, Australia. In my spare time, I enjoy the culinary arts, biking, kayaking, and photography, most recently adding drone photography to my line of new endeavors. So if you have any questions at all for either of us this evening, please type those in the chat. We will have our team of lead teachers standing by monitoring the chat to try and get those answered for you as soon as possible. So now, without any further ado, I would like to turn the dialogue over to Erin so she can get us started with this evening's presentation.
All right, thank you, Greg. And thank you everybody for joining us on this here in Colorado, snowy evening in March. So our focus tonight is on sustainable invention and how we can inspire students using this idea of sustainable invention, while also exposing them to green chemistry as well, and meeting standards in the classroom. So Beyond Benign, in partnership with the Lemelson Foundation a few years ago, and a team of classroom teachers, developed a curriculum that we are going to focus on tonight. And this curriculum serves as a tool for really fostering interdisciplinary ideas, lots of student-driven exploration, invention, and engineering. We will be sharing the link to this guide tonight. I will mention, though, that Greg has been hard at work at an updated version of the guide, and that should be coming sometime later this spring as well. So that will have some awesome updates in it. This guide itself, this exploration into green chemistry and sustainable science, is focused on bioplastics. So our purpose here of the guide is to introduce middle school students and their teacher facilitators to both sustainable invention and green chemistry principles. And I will say, while it's focused on middle school students, I do believe that with just some minor adjustments, it's also very appropriate for high school students as well. This guide and this curriculum really focus on two sort of essential questions. How can we, as student inventors, make a product that is good for both the people and for the environment? And why should we, as inventors, student inventors, really care about the idea of sustainable science and using or thinking about invention through a sustainability lens? So some overall sort of enduring understandings that we want kids to take away from this particular curriculum is the idea that green chemistry is this wonderful way where we can create products that are both safe for us, safe for the environment, and also sustainable for our future. We also want them to walk away as inventors. So throughout the course of the curriculum, they will be inventors. So they will be inventing new technology, focused specifically with bioplastics. They will come up with an idea of what, lots of times starting off actually with a problem that they see, and then an idea of how they might solve that problem using bioplastics, and then going ahead and figuring out like what can they invent, and going through the iteration process with lots of multiple opportunities to test their product, get lots of peer feedback, and take all that peer feedback and test results and reiterate. And we also want them to understand that bioplastics can be really versatile, and we can do lots of things with them. So if we connect this back to the next generation science standards, I just put the middle school performance expectations in here. But again, I do think there are some great connections for high school and GSS standards, particularly with the engineering focus. So there are two performance expectations that this unit meets in the physical science realm. NGSS, for those who are implementing in their particular states, is three-dimensional science and learning. And so in addition to the core disciplinary ideas, which involve the performance expectations, the students are actually figuring out the science through the science and engineering practices, and using the cross-cutting concepts as big themes to tie everything together. So this curriculum does a wonderful job of focusing on problems, solutions, and patterns. We have also developed this curriculum using a phenomena and storyline methodology. So really quickly, phenomena-based learning is basically when you have an anchoring phenomena at the beginning of your unit. And this is something that is puzzling, that we can use science to figure out. And phenomena, really good phenomena, have oftentimes both a global context and a more personal context for kids. It's very learner-centered, so the learners, think about the phenomena, come up with lots of observations and noticings and wonders, and then as the learning facilitator, as the educator in the classroom, you use those questions that the kids have come up with to kind of guide the learning. We also have approached this curriculum through a storyline perspective. So this is really just this storyline kind of helps tie all the different lessons together. So there's always a purpose for the learning that the kids are engaged in. Storyline is really focused on collaboratively setting up situations and learning experiences where kids can work together to figure things out, and it's very purposeful. So you're moving from one lesson to the next, kind of as you move through the storyline to figure out the anchoring phenomena. And we have found, or I have found personally, I think Greg would agree with this, that green chemistry is this beautiful fit for helping kids contextualize the content we're trying to help them understand within this framework of phenomena. So some kind of general curricular practices that you will see emphasized throughout the guide itself, and then the lessons we're going to share with you tonight that are part of this curriculum, is that you will see that there's always this context that we're providing that's based on the phenomena that we will engage remotely with tonight. The kids will also be developing empathy as they move through the lessons, and ultimately they will in part use this empathy that they developed to invent products, and those products they will go through a cycle of iteration to make them as good as they can make them be for whoever their end user is. And throughout all the lessons, there's always an emphasis on giving or providing students opportunities to really explain and make public their thinking. So just a really short definition of what green chemistry is. And rather than read it, I'm just going to give you about 15 seconds to go ahead and review this definition really quickly before we go to the next slide. Okay, so green chemistry really is about the intersection between the idea of using safe materials and creating safe materials for both the person and the environment and the people exposed to those things. It's about being cost effective, and it's about performance. So we want something that is going to perform as well as a traditional product or a traditional lab, things like that. So it's really about finding the intersection between those three. And we're going to come back to that sort of intersection in a little bit. So this particular graphic right here, when the revision of the original curriculum started to happen over the last year, Greg and I kind of sat down and looked at all of the lessons and sort of chunked it out into sort of 3 different pathways that teachers could take depending on what their end goals were in terms of what they wanted the kids to engage with. So in that second column there, this is really more of a focus on just green chemical essentials, green chemistry, sorry, essentials that you might incorporate through a physical science class. So you can see that we've just check marked, maybe about 1/3 of the activity. So this is just getting at really the core ideas of green chemistry. The next column is really more of a focus of both the green chemistry essentials and an application opportunity for students. And then the last column, the focus is really on using green chemistry practices to design, engineer a product and go through that whole design cycle with the kids. So as we work through the curriculum tonight, we're just going to highlight some of the really important features of each portion of the curriculum. So we won't be able to, of course, do everything, but we wanted to at least kind of touch a little bit. So what you see highlighted in orange there is really the phenomena. So this is kind of getting students engaged, exposing them to the phenomena, and then giving them some context for what they're going to be working towards, throughout the unit. So our big why is we want, first of all, students to really think about what some of the problems we have with plastics in our world and the implications of our very heavy plastic use as a group of humans. In general, many of us, I think, have probably experienced that kids really like to learn through a context of how can they use what they're learning to make some positive change around them, maybe locally or bigger than that. And the ideas of green chemistry and invention education are really awesome tools to create those experiences for kids, so they can actually experience firsthand that small changes do make a big difference. So we are going to push out to everybody a poll right now that both Greg and I use to kind of to lead off this particular unit, and this is really just to get kids thinking about their plastic use. So I'm going to go ahead, we'll give everybody a little bit of time to answer the 10 questions that are on your screen in front of you, and then we will take a quick peek at the answers. So basically, you just want to go through and is this the phrase or that you see in front of you for each question? Is that you or is that not you? You can do this through a digital poll in your classroom. You can do it more like a kinesthetic activity where kids are standing up and down. You could have them moving around the room based on if they agree or not with the different things. So there's lots of ways that you could introduce this to kids.
And we might add that it only allowed me to put in 10 questions and we had 11 slides. So this last slide I have received or sent a package that contains packaging peanuts, bubble wrap, or air pillows. You won't have that in your poll, but just kind of think about that because that's where we're getting ready to head to next.
I think we're probably good, Greg, because I didn't do the poll and I'm guessing you probably didn't either.
Nina, can you go ahead and share the results?
Oh, that's right. Thanks, Nina. Let's see. So you can take a quick look through here. I think this is a really great just activity to start getting kids thinking about what things do they have in their life that are plastic. There's a lot of things on here that kids are really surprised about. Things like just their backpack or nail polish or even their computer. They don't usually associate plastic with their computer unless they think about it a little bit. So it's just a great way to help them understand or help them start thinking about how often they use plastic in their life. So after they engage in this initial poll, then we introduce our phenomena. So in a moment, we're going to show you a slide that has pictures of the phenomena. We are going to, Anina's going to drop a link to a Jamboard in the chat. And what we would like you to do is just record some of your noticings. What do you observe and what do you wonder about the images that you're going to see on this slide that we're about to share with you. So just some context here, we've got traditional packaging peanuts on the left side. The packaging peanuts are in just water in the jar that's on its side, and they are in acetone on the right side. And then we have biodegradable packaging peanuts on the right side of the screen. I have done this both as a class demo, and I also did it, I did it recently with a group of kids just on a small scale. So each individual kid experienced the phenomena at their own table. So we would love for you to hop onto that Jamboard, and we'll give you a moment or two to add some noticings and some wonders. And the Jamboard link is in the chat. So we've got some nice questions coming up, wondering if what the peanuts feel like after they've been in the substances, wondering what they are breaking down into in the various jars. Some noticings about what's dissolving or what appears to be dissolving, what's not, wondering if they have opposing polarities. So those are all some great noticings, great wonders. While you continue to wrap that up, back on the webinar screen, we can see some actual student observations from this activity. So lots of students, notice the dissolving, but they also noticed that it smelled kind of yucky with the traditional peanuts, but there wasn't any kind of smell with the biodegradable peanuts. Another thing you can do is go ahead and do like Padlets, other or a Jamboard just to kind of put everybody's ideas together. What we're going to do next, and this is what we have kids do as well, on the second slide of the Jamboard, we're going to have you respond to the prompt, what might be a deciding factor in the choice of a material used to make a product? So if you want to head over to that second slide on the Jamboard, how might we decide what material we're using when we make a product? So I see cost, I see durability, designing for degradation, how well it works, so performance, how will it affect the environment when I'm done with it, safety, reusability. The availability of raw materials, how easily you can get those raw materials. Back on our webinar screen, there is an example of what kids come up with. So I can see some similarities between what kids come up with and what our participants tonight do. And I see some things that we came up with that they didn't. One of the things that really sticks out to me is that as educators, maybe with the green chemistry perspective, there's a couple of us that talked about safety. So safety of the products, the materials to make the products, and the safety of the end product. That's something that kids oftentimes don't think about. So safety is not necessarily something they think about when they think of plastics. They think about things like cost, and they think about performance. So just something to remember if you engage in this activity is that the green chemistry is, of course, bringing together performance, cost, and safety. So this idea could be a great segue into what is green chemistry. And Greg, I don't know if you want to go back one slide and so we can just show them really quickly the picture on the left. So the picture on the left, the students are given these just little blocks, and they walk around the room and they look at what sort of materials are making up everything that they see in the room. And they put a block in the cylinder if they see plastic or wood or metal or glass. And it's a really great way, just a visual way for them to see that usually we have so much more plastic in our space than many of the other materials that are out there. So again, just a nice visual for them. Okay, so after they've thought a little bit about plastics in their own life, so we've provided like a personal context for them, and they've engaged in the phenomena. Now we spend a little bit of time just figuring out, like, what is a plastic and what is a bioplastic, and we bring in life cycles. So what does the life cycle of oil-based plastic look like compared to a bioplastic? The text you see on the left there is coming directly from the curriculum guide. And then the text on the right, this is, I like to have the kids just do like sorts and try to figure out what the life cycle is, just to help them think about, like, where do these products come from that they use in their everyday life, oftentimes without thinking about where they came from. Another thing you can do is this idea of a pair square share chart. So, having kids think about with pairs some of those questions on the left, and then eventually maybe coming to consensus class. Another idea is doing some comparison just with a simple Venn diagram. So what are the similarities and differences between these plastics and bioplastics? So from here, we move right into this first introduction into green chemistry, and coming at green chemistry through the lens of sustainable invention as well. So there's a lot of sort of terms that are introduced right now: sustainability, invention, and then we can see down there, there's the interface with safety, cost, and performance for green chemistry. All right, so that's sort of the introduction to the whole unit. So next up, we dive right into, how do you actually make these bioplastics? So here are the steps. The students love this. There's so much excitement generated when they're actually making bioplastics, and it's been so fun to watch them because they love those final products. So in our bioplastics are basically made from water, starch, usually tapioca starch is our starting starch, and then sorbitol as a plasticizer. The kids make the bioplastics, and then they go through their first evaluation cycle. They do 3 versions of their first bioplastic. The very first version is everyone's kind of doing the same thing, so we're getting some consistency, and then the kids have a little bit of freedom to change some things in the recipe. So we like to have them evaluate that by looking at, what did they come up with, and then comparing those to what their classmates came up with as well. So when they evaluate, they think about things like flexibility, they think about things like elasticity, they evaluate where are all these materials coming from that they are using, and they think about, like, why does that matter? Like, does it matter if we use cornstarch or tapioca starch? Where does the tapioca starch come from? How far is the corn, starch traveling? And then we do go back to, is it biodegradable? The next piece of the curriculum is, again, some more iterations where they really can kind of dig into figuring out how to create a bioplastic that meets criteria that they themselves have come up with. So we introduce some different variables. So we talk about, like, acids and bases, and what we can add to our recipes to change the final bioplastic product. So there's a lot of optimizing that goes on, lots of material testing, lots of comparing, lots of sharing ideas with peers and getting feedback. And then you can incorporate some clean evidence reasoning statements in there, where kids are sort of defending the ideas behind their products and using evidence to support those ideas. So I think we're going to play a couple videos here of some of the products that kids came up with.
So this bioplastic was made of 10 grams of baking soda, 10 milliliters of water, 10 milliliters of sorbitol, and 10 grams of potato starch.
We found that this bioplastic is very breakable and it's very fragile, and now we're looking to see what we can do with it.
We are testing to see if it dissolves in water. We're also going to see if we can grind up the powder and what we can do with that powder.
So we made a cornstarch bracelet, ring, spring, basically, and a couple of just normal lines. And we made it with a double batch. So we added, instead of 5 grams or 5 mils, we made 10 grams or 10 mils. And we had level 3 heat instead of level 2 heat. And we found that they are much more flexible. So you can, they have a lot more flexibility and elasticity, especially the spring one, which can be pulled really far apart. But the lines, however, they're a lot more flexible and not as elastic. And then
So we had a squishy recipe
again
for the bioplastic, and then we had a kind of crumbly recipe. And whenever it crumbled down into like a powder, we were able to coat the squishy recipe in it, and then that made the squishy recipe bouncy instead of just being sticking to everything.
All right, so lots of great thinking from those kids, and lots of, you can see the just the different iterations that they're going through. The final piece of the curriculum is really thinking about how can I use the product that I've made, or how can I make a product that is going to serve a very particular purpose. One thing that I've done is tie this piece of the curriculum to the Sustainable Development Goals. So again, we're providing some really real world context for the kids. So they pick a goal that they think they can address with an invention that is made out of bioplastic, and they use that kind of as a framework. So the other thing that is really the opportunity presents itself to do, if you can get into the invention and engineering part, is again, really think about using the design thinking cycle to figure out what is my particular goal, who's my end user, how am I going to meet the needs of my end user, and then based on what you're trying to create, what properties do I need to make sure that my bioplastic has in order to create this product that my end user needs. So here are a number of different prototypes. that kids have made. Some kids have found that they use clay to make kind of a mold, others do not. So we have a wide variety of ideas happening here. A couple more prototypes. This one on the left, this bioplastic adhesive, that I just had a couple kids make that a few weeks ago, and so they wanted to make a glue, a bioplastic glue, and they kept going. We didn't have enough washers, so they ended up adding a backpack, and their glue was super strong. I think they got 30 pounds on there before it no longer was able to hold together. So kids can really take this where they want to go. I had the other picture here is a student, as you can guess, was in the middle of the pandemic and really was just kind of horrified by how many masks were getting thrown away, and wanted to make a bioplastic mask to maybe address that problem. So lots of creative opportunities. All right, so that is a lot of me talking at you. So what we're going to do now is hop into breakout rooms, and we're going to give you a couple resources that Nina's going to put in the chat here. And what we would like you to do is take a look at these resources and have some very specific group discussions about your thinking on these resources. So we've got the pros and cons of using biodegradable packing peanuts document. And then the Orb-It activity is something that Greg has created. So Greg, do you want to talk a little bit about that before we jump in there?
Yeah, and I want to say also that when you go to these rooms, we're running short on time. You're not going to have time to delve into these too in-depthly. I just want you to kind of look through them and get the idea. Yes, the Orb-It activity is a way for them to evaluate a product and look and see how green it is. So I think it'll be pretty obvious, and you can kind of jump on to probably number 4. I think the directions say, pick one of the styrofoam or one of the packaging peanuts that you want. You can really do it for any product. I just wanted you to see the tool and see how they use it. When we come back, if there's time, I'm going to show you a sample of a student one that actually took it like a little bit further. So yeah, Nina's going to put us into breakout rooms. And if you would please, the breakout rooms will not be recorded. That portion is not recorded. So if you would feel free to share your camera while you're in the breakout room. It just allows for a little bit more intimate and engaging conversation that goes. All right, is everybody back?
Yep, everyone should be back.
Everyone's back? Okay, sounds good. All right, I would just like to go through and hear just a very quick wrap up, like minute or less, since we're running a little short on time, of what you kind of discussed in your rooms. I don't have the numbers here, but Veronica, could you let us know what your room was talking about?
We just talked about really wanting to try to use more natural products. How we talked about cost could be a real factor. We were thinking about alternatives for packaging things. What other things we could use? Somebody mentioned using T-shirts or newspaper, or ways to get away from always using these styrofoam kind of products. What else did we? Help, ladies. What else did we talk about? Trying to think.
That's it, Veronica. You did a great job. Yes, we talked about things like using cardboard and other resources. We went through the pros and cons sheet and kind of went through the questions as if we were the students. So that's what we did.
Okay, good. Thanks.
Did you not make it to the Orb-It?
No, we were so enraptured with the first part.
That's
didn't
fine.
get there.
That's fine. All righty, Vicky from the other room, could you speak for us?
Yeah, we kind of we skipped to number 4 and did a lot of evaluating on. We thought this would take a lot of training for not only the teachers but the students. You'd have to put some time into them leading up to it. But I'm pretty excited about it. I'm just getting into this, so I appreciate the opportunity. And I think I think my kids could get it. They're just going to have to learn to evaluate themselves better.
Right. Yeah. That's a tough thing for kids to do. Thank you. Thank you, Vicky. Ken, could you share from your group?
Sure. Or my group members could share. So we talked about biopolymers and Allison shared some ways in which she was using biopolymers with her students. We started talking about the different forms of polymers, and that just kind of organically led to another conversation. And then James was talking about different applications of polymer. We talked about the different formulations, and James was talking about the importance of using or getting the right mesh size for the particles so they work effectively. And then it devolved into a reminiscence because in Canada we don't network as well, and so I finally got a chance to meet James after hearing about him for many years.
Very well, thank you. Scott, do you have anything for us?
Sorry, having some technical difficulties. I would love to call in Jill. I'm trying to see cameras. I don't see cameras. Yes, Jill's and Winnie to share out some of the things we talked about in our breakout room.
Winnie, do you want to go first?
Okay, so yeah, actually, in my class, I already, I mean, for the student project, for the end of the class, actually they have to do some research about the plastic, and then about what happened for the environmental, and then their critical thinking also, and then by the end of their research, they have to make for the upcycling from the products. From the plastic. Yeah, so each one of the students make something that useful for them. Yeah.
We also spent a while talking about discussion facilitation around this. So thinking about it from the perspective of a high school teacher, one of the things I would be interested in doing with the packing peanuts is to have students analyze it through the framework of the 12 green chemistry principles, because I think for high schoolers that could elevate the complexity while also providing a framework that they would be able to fully engage with. So we talked about that, and the Orb-It activity is kind of discussion facilitation tools for high schoolers, which could be cool.
Thank you, Jill. And finally, Erin.
And thank you, Winnie.
We started off actually on the Orb-It tool and kind of looking at that and figuring out like how could we use that? How does that work? How does that incorporate the kids, again, having opportunities to think about the green chemistry principles and apply them to these products. So we're thinking that that's a really great opportunity to really engage with data and then to visualize what that data looks like using that tool. So thank you for inventing that, Greg. And then we spent a little bit of time, not so much looking at the pros and cons of biodegradable packing peanuts, but really kind of thinking about like how we could use that pair, square, then classes of one chart to get everybody's ideas out on the table and maybe come to a consensus on some things.
Great, thank you. So as we look at that Orb-It tool, this is a sample, a student sample. So yeah, they can do it. At the simplest form, it's just the 1 through 10, just the rating, and then they make the arc and they color it in. I know that's hard to tell because it's a photocopy of black and white, it was an actual picture. But the extension here I did with the kids, I gave them the math. So, and I'm not going to remember it offhand, I would have to look at this, but they actually calculate the area that's covered. So they draw their arc, they calculate the area covered by each of the 3 pie wedges, and then they come up with a percent. So they can actually give a value for how green that they think their product is. So this group came up with a green score of like 51%. So they can do it. And it really, you can make it as simple or as complex as you would like based on your students. So, all of this meets a need that we've been talking about this evening. And as we here at Beyond Benign believe that if you tell a teacher about a resource, they're going to know about it. If you give them the resource, they're going to use it, but using it is the difference that, we really want to make by providing resources for K-12 educators. One last thing before we sort of wrap up is talking about student impact. I got this email at the beginning of this year from a student. Hello, Mr. Sloan, this is Gabriel. I had you in 8th grade in 2021, where we did a program called Green Chemistry. I was wondering if you could provide me more information. We're doing the Innovate with Indiana program in my engineering class, where we're supposed to develop a business plan and present this for the chance at a scholarship and business opportunities. My group was looking into making and selling cornstarch bioplastic products. So it just kind of comes full circle when they reach out, 2 years later, and remember something they did in your class. So that was kind of a great moment. And that sort of wraps up our presentation for this evening. So please join us again for our next Observe, Wonder, Think, which is on April the 20th at 6 p.m. Eastern Time. As always, please feel free to check out and share all of our resources that we have online at beyondbenign.org. If you happen to be attending ACS in March here in Indiana, please stop by booth 314 to say hi. We're gonna have 3 presenters at the event. I'll be presenting on Sunday. Dr. John Warner will be speaking on Monday, and immediately following that, Juliana Vidal will be presenting on marine biorefinery and green chemistry education. You can take a QR code snap there to get the information. I go through these every week, so just quickly, or every month, so I just quickly go through these. Again, launching this summer is going to be the Green Chemistry Teaching and Learning Community. Come back the next 2 months because I can give you a bit of a preview. That will be the topic of April's discussion. It is a resource hub that will host a central online searchable library. It will allow users to create profiles, connect and network together, share ideas and resources, collaborate and receive and give feedback. So sign up for the newsletter if you have not done so already. The project team will be reaching out to those in the newsletter list to help with some testing of the site. So you want to get on that early. Don't forget, we do have online summer course opportunities as well. And one last time, we would like to thank all of our supporters and sponsors who make this event possible every month. Don't forget to sign up to have a chance to get your free green chemistry book in the giveaway. And finally, one last time, thank you to Erin for sharing her time and her talents and her positive energy for the green chemistry community. We will be dropping a link to this evening's presentation, as well as a link to the Sustainable Invention curriculum in the chat. And we'll also put those out in the follow-up emails as well. There will also be a feedback form in that curriculum folder. We would love to hear back from you if you use any of the materials that you find there. So again, thank you for joining us. We look forward to seeing you again next month. Good night and be well.